Okay, so good afternoon also from my side. So my name is Bojan Vrhovnik. I'm a cloud solution architect. Yes, I worked as a police officer for 1 year. Then I decided to go to college, start programming, and then I was basically addicted. And then I moved, I started working with community, and then I moved to Microsoft to work on specific stuff. So as a cloud solution architect, I work mostly with partners, enabling them to basically accelerate the path to the cloud. And one of the jobs that I have is basically to help them, overcome technical problems that they might incur with the help of proof of concept, hackathons, and those kind of stuff. So I mostly work with different different technologies, and one of them is also Kubernetes that I'm kind of working with. So today's session will be about scaling. So the idea of this session is basically not go into how Kubernetes work from the perspective of management, patching, and those kind of stuff, but rather to see what kind of options do you have when you need to scale. So with scaling, I'm talking about two types of scaling. So the first one is the vertical scaling, where we're talking about adding a new virtual machines to the cluster, new workloads that needs to handle the load. And the second one, I'm talking about adding different types of machine to the cluster itself. So I'll be talking about a little bit about node pools as well. The second part that I will be focusing on is basically how to scale with containers as such. So how to scale horizontally with containers. I'm not talking about just increasing the replicas load to handle all of the requests that are coming in, but different ways how to basically react on specific changes. Not just on the requests that are coming in a sense of a usage of CPU and memory, but also on the possibility to handle load based on some third-party external events that are coming into play. So we will be talking about horizontal pod autoscalers. We will be talking about KEDA. We'll be talking about virtual kubelets that I will be kind of demonstrating what is that all about and how you can scale basically in seconds. Just to recap, previous speaker has did a really nice job explaining what Azure Kubernetes Service in essence what it provides to you. So to focus on just on one part, we need to understand how Kubernetes architecture looks like. So I won't go into specific details, but just a refresher so that you have a understanding, especially when we'll be talking about virtual kubelet, that you understand what different components do and what they're here for. So we have a managed. So I'm talking about in a Azure sense, so Azure Kubernetes Service sense. So we have a managed plane, which is a master node, which handles all of the requests that are coming from either from the user, either in a sense of kubectl commands, command line commands, either from managed libraries. For example, you have managed libraries from C# that you can control the cluster itself. You have PowerShell scripts, you have a lot of scripts, you have Azure CLI. So you have a lot of options how you can then work with the master node itself. The things that are doing the job on the end are the worker nodes. So the worker nodes are the one that are getting all of the information from the master node. And there is one component on this worker node that is important. This is basically a kubelet, which is in short a daemon, which is then communicating back information with the master itself, giving them information about what is happening on the worker node itself. So then we have Docker engine in this case that is basically handling the load of containers, instantiating containers, starting containers, and those kind of stuff, and other components like kubeproxy that is handling all of the IP allocations and those kind of stuff for the pod itself. So Kubernetes is a really nice, interesting product because everything here it's quite pluggable and extensible, and you will see during the presentation that you can do a lot of stuff on your own. So I'm not talking just about Microsoft stuff. I'm talking about stuff that is already there. So if you're working with different open source stuff, you can use that, of course, as well, but we have some stuff that is integrated in the platform itself. So let's go to a demo. So I'll be doing a lot of live demos, and hopefully internet will work. So the first things that we will go, basically we will see when you create a cluster, as previous speakers have shown. I won't focus on, on all of the details, but I will focus on one part. And this part is basically first defining, the primary node pool that will be used behind the scenes. Now, when you have only one pool, then you can scale up, scale down, without any problem, directly from the portal or from the script itself. But the interesting part here is basically the scale option. So with scale option, you have two options that you can then select. So the first one is virtual nodes that we will look into a little bit later, but you also have something that is called virtual VM scale set. So this is something that is done behind the scenes in order to enable autoscaling part. So when you do this, I already created a cluster because we don't have time to wait for cluster to provision. So when you have a node pool, in this case, I can easily, it's still in preview, of course, but this will hopefully be in GA soon. But I can add, a node pool in this case, where I can select either to have Linux or either to have a Windows-based virtual machines with specific sizes. So I can define what kind of size will I have, and so on. So when I have this pool enabled, and if I enabled autoscaling as well, as a feature to the cluster itself, I can then manipulate how I will do the scaling part. So in order for me to use the autoscaling, I can enable it, of course, via portal. So what we will do now is enable autoscale option. So we will do an autoscale for this one and define that the upper limit will be 3 nodes. So I don't want to spend too much money, so my boss will not be mad at me. So it's really easy way how you can enable autoscaling from the Kubernetes perspective. Now, what is happening behind the scenes, we will see a little bit later. But the idea is that that autoscaler node is installed as a component behind the scenes, and it's basically monitoring the requests that are coming on the Kubernetes cluster itself. Okay, so I can of course use scripts as well, but there's also one way where you can see how the cluster itself is built. So we have something that is called Resource Explorer. So if you write into URL, if you have a Azure subscription, resources.azure.com, you will get to one portal where you can see how what kind of information is sent when you do REST calls. So here you also can then take this information and edit it directly into the browser. But what you also get is something that is really interesting for me. So if you're doing Ansible, you get, for a specific resource to be created with all of the necessary information behind the scenes, you can get scripts that are inside of the browser itself. Of course, for PowerShell is the same story. So it's really easy to basically script all of the stuff that you want to have then behind the scenes. Okay, so this is really simply how you can add stuff-based worker nodes based on the cluster that you already have, because if the request will be coming in and the node will be have enough data to see for the threshold, it will automatically then scale to the nodes that is there. Now the default time is basically 5 minutes, but every 15 seconds is basically checking for differences, between the values for checking if he should scale or not. So these parameters are available on a link. In my presentation, you will have a link, and you can check those parameters that Azure Kubernetes Service is basically checking. Unfortunately, you cannot control them now, so this is done by Azure. But I believe that in future we will probably have an option to do that. So this was an easy demonstration how we can do that. But one is adding nodes to the cluster itself. But the other part is basically how you can configure for stuff to react on those metrics that are basically important for you. So how you can define how to scale automatically. So if there is a lot of burst of load, for example, in a specific workload, how you can then do the load itself. So every Azure Kubernetes service has something that is called horizontal pod autoscaler enabled by default. Before version, I'm not sure which version, that you needed to install this autoscaler, as an add-on. But now you have this built in. So the idea of this is that it collects the information from the metrics server behind the scenes. Now, before there was a component which is called a hipster, before version 1.12, I think. Yes, 1.12, yes. Which basically, the idea of this is that it collects all of the information from the nodes, how many pods are instantiated, how many memory is used, how many disk is stored, how many memory, and then it's basically sending this to a master, and on the master there's a hipster component that is basically collecting all of this stuff and doing information based on that. Now they changed that stuff, and they now have a metrics server. So when you go back to the cluster, I will show you will see that there you have a lot of pods. And in that pods, you have deployments, and in that deployments, you'll see that you have special pods that are running that are called metrics server that are basically collecting, aggregating all of that information for you to use. There is a component on the kubelet which was called C-Advisor before, which were basically sending that information back to the aggregator. But now we have an API that is handling all of that load. So let's see this in action so that you can see how this works in practice. So let's go back to I will close this one. So what I have currently, I have two nodes. You will see that I have something that is called virtual kubelet, but that is something that we will discuss a little bit later. And if I say to the cluster itself, give me basically a horizontal pod autoscale, you will see that I don't have any of that enabled in my cluster. So let's do something, and let me show you pods. So I have currently few pods that are running behind the scenes. So the pods are basically the single unit of execution that is running the containers that I'm trying to work with. So here you see that I don't have any special pods. So what I will do now is I will run a script, a simple application. This is a PHP application in a Docker container that does really simple calculations. So what it does is basically for million iterations, it calculates the square of the specific entry. So it's basically just basically pushing up the CPU a little bit so that we can scale on the end. So let's run a deployment. Let me just do it like this. So let me run this deployment. So what I will do is just also limit the request so that I will have 200 milliseconds for this image, and I will expose it so that it will be available through port 80. So I'm not exposing it as a service, so I will not request a public IP because I want to just test it internally. So we will need to be a little bit creative in order to basically stress test this specific deployment. So if I run this, now the deployment is already I already pre-created the deployment before. So if we go to the deployment, you will see that I have this PHP Apache already there. If you go to kubectl SVC, you will see that for the service part, I do have a cluster IP for this deployment, but I don't have an external IP. So just keep in mind that all of the components, majority of the components in Kubernetes are exposed as pod. So you can, if you want to be unsecured, you can expose whatever you want outside to the public world. So for example, if you want to expose Kubernetes dashboard to be available for everyone, you can just expose it as a load balancer. It will be available to everyone. So okay, so let's do a deployment. So let's define rules that we want to have for this to be autoscaled. So what I'm doing here is I'm defining that I would like to have a deployment which is called PHP Apache, and I would like to have that for if it goes over 50% of the CPU, I would like to scale up. So I would like to handle that load, but not more than 10 instances. Now by default you will see that this I will run it. So now I can get back the information, and now we will see that I have basically a horizontal pod autoscaler named PHP Apache that has currently a threshold of 50% of the CPU, but I don't have any load on top of that. Now for us to see how this works, I will run a container that will have a busy box. So I'm running simple container that will be named load generator, busy box. It has inside, it just has a few simple tools. So what I will do now, I will now do a classical approach with load testing. So this is the simplest one, how I can see how this works. Basically sending requests to that specific SVC PHP Apache, so that we can see how that works based on the C. So you can see the result. So what I will do now is go here and say kubectl pods, and let's watch what happens behind the scenes. And you will see that pod will start when the load will be after 15 seconds. It will start basically popping up pods that are getting the request inside. So we should see it in a few seconds. Now I will open another one. So if you imagine, I'm connecting to the cluster from 3 different types. So let me go to HPA and let me watch that as well, so that you can see how this will now aggregate all of that information, send it back to the master, and when the request will come in, you will see that it will start loading the creating new pods. Let's give it a few seconds. So if you notice behind the scenes, the pods are still started to basically to run. You see that I have 216% of the CPU that is loaded, and now when I stop the request and exit this one, you will see that this one will start killing the pods and getting back to the normal state that I wanted to be in. Okay, so based on the requests that are getting in based on the load, I can easily scale with autoscale functions to see how this works. But what is the problem? What is the main problem here? So the main problem here is that I'm doing this with 2 simple things. So I'm doing this with the metric server that is built in. So I have that metric server is basically CPU and memory. Now with version 1.16, I can do also custom metrics. So I can, for example, have a number of HTTP requests. So if the number of HTTP requests is, I don't know, 200 with HTTP status 200, I can do, again, I can do load and I can create new containers in this case. But what if I want to have something a little bit more, let's say, specific? What if I want to have, for example, load based on events? What if I want to have Kafka, for example, that can handle, automatically events that are coming in. What if I want to have, for example, a storage queue that somebody is sending an event? I want to process that event, and instead of me doing all of that scaling, defining rules, defining conditions, how this works, what if I have, for example, mechanism that can handle all of that stuff? So what we have, and this is something that we cooperated together with Red Hat. So Red Hat worked together with the team of Microsoft engineers in order to create a tool which is called Kubernetes-based event autoscaling. So the idea of this tool is basically to have one really cool stuff, and that is basically an ability to react on external events. What it does behind the scenes, it works as a metrics server. It works basically, it has a special object which is called scaled object, which then reacts based on the events that are coming in, and then gives information to the horizontal pod autoscaler to scale from 0 to specific number. So now if you imagine, so you have, for example, I don't know, events that are coming in that you need to process some specific stuff, and you want to basically scale based on the message that you're getting in. Not kind of, imagine that you get 100 messages, now you want to, process those messages with ease. So each of the functions that will basically take that message should process some workload that you're defining. And instead of you taking care of scaling that part, KEDA can do that. KEDA can do that instead of you. So as you can see, it uses a lot of scalars. It uses and all of them new are added as we speak. There is also one thing that you need to be aware. It's open source, so you can go there and check the code. You can go there and play around with it. It's based on the idea of Azure functions. So we have something that is called Azure Functions, our serverless offering. And before it was only possible to run this Azure Functions in cloud. So the idea of Azure Functions is basically you react on some specific trigger. That trigger can be HTTP, can be queue, can be whatever, and then you perform some actions, and then you give the workload to somebody else. It's serverless offering, which means that you don't care if this runs on Windows, Linux. Depends on the needs. The only stuff that you care about is two things. So, how many power do you need behind the scenes, and what kind of best practice will you apply? So, will you do the execution, just one execution, or will you fan out, or you will do another one? So it kind of gives you an ability to focus on your needs. So before, only the Azure Functions were only possible to run it in the cloud, but now you can run it on edge devices. You can run it as a container, and since you can run it as a container, you get all of the functionality that Azure Functions provide, and that is basically one of them is also autoscaling options. So let me show you how this works in action. So let me go back to my cluster. So what I will do, I will create a new folder. I will say that this new folder is sample. I will go to this sample. So when you install tools, you have an option to work in, I don't know, Visual Studio, or you have an option to work in the CLI as well. So you can use whatever tools you want, Linux, Mac, whatever. So let us create a function, and let's say that we want to have a Docker support. So I will select, in this case, Node, JavaScript, and if I check what is inside, you will see that I have simple, minimal stuff that I need to have here in order to run. But it automatically added a Docker file as well. So if I do a Docker file, you will see that this Docker file contains, our our image that contains Azure Functions runtime in order for it to run the application itself. So what I can do now is just say, give me a new function, and I can select from a lot of options here. I can say that I would like to have a classic, a classic queue trigger. So I will react based on the queues that will, based on the messages that will go into a queue. So I have a message which is a text message, maximum 8 kilo in size, that I will send inside of this function, and this function will then process those images and then return back some information. So this is a really simple application. So if we use a little bit smarter editor, in this case, for example, code is one of the options that I can use. You will see here that now what I get is in this queue trigger, I get a simple code that is behind the scenes is basically just getting reacting on some queue information and then basically processing that queue. So it's nothing special. Okay, so we can do a lot of stuff inside of this code in order to see how this works. But what we will do now is basically just change a few things. So the first thing that we will do is define the connection string. So I go back to the portal. So I already have an Azure Storage account created. So I will go here and use this access key. I'm just showing you what I will do so that you can, see that the messages will really come in. So I will go back to this function. I will define the connection string for this one, and then so I need this one. Okay. So I will copy this, and then I will define that I would like to use a connection string, which is this web store. Then I need to define one more thing. So there is one thing that I need to define, and that is that I would like to use an extension bundle with the help of this part. So I will go here and define. So this is the minimum stuff that I need to do in order to run this application. So if I open terminal, and in this terminal, I can see all of the stuff and say func start. So I would like to start this function so that I can test out functionality of this function. So it will run all of the necessary file. And if everything is okay, I should be able to send information from the storage. So already logged in, so I can do here a message, for example. This is a test from stage, and I'll send this message. You should see that this message should be, received. At least in this case, JavaScript process the message. This is a test message from stage. So this is a simple kind of the simplest Azure functions that I can do. So it will react on the changes that are coming from the outside world. So how I can now, use KEDA, and how can I now basically combine all of that stuff that you're seeing here with Kubernetes that I have on my cluster. So what I can do now is, let me go back here. The next thing that I will do, so I will go to the already created demo. So it's the same demo that you saw me doing step by step. I'm going to this demo because I need to create a Docker image. I need to push the Docker image, so I already have the Docker image pushed, so that we don't have any surprises regarding the internet. So what I will do now is I will say, since these tools since KEDA is enabled with Azure Functions tools, it will automatically create all of the necessary components in Azure in order for me to run event-driven auto-scaling options. So in order for me to do that, I need to install KEDA. Now, if you noticed, there is something on the end that is called namespace KEDA. So I will put everything in a special namespace in the cluster. So when you will be searching for pods, you will not see the what has been installed if you don't use specific namespace. So when I do this, it will go directly to the cluster, and now it will install additional stuff. So it will create a service account. It will basically create a few components that is called OSIRIS, and there you will see also there's a lot of components that are installed in order for this to work. So, and one of them is also scaled object. So what we'll do now is we want to run this in a container in Kubernetes. So how we do that is simple. So we use again tools that were built by the Microsoft and Red Hat guys, where I define that I would like to deploy something that is called Hello KEDA. And now I would like to do this to a specific registry. So by default, it uses Docker Hub as a registry. So I will push all of this container that you saw as a Docker file to my Docker Hub space registry, and then I will use this in my container. So let me run this. So I will run a Docker build on that image. Now it will try to upload that image to my registry. Now, since I already have the image created, it should be done really quickly, and then it will run a deployment inside of the cluster. Okay. So when this finished, you will see something interesting. Give it a few seconds. Okay, it's pushing. This should be quite quick. And then what we will do is we will go back to the cluster, and we will basically see the pods. So in this case, there are no new pods added. So, okay, so this should now finish. So imagine, so now if I go back to this picture, so what we have now, so we have a KEDA installed, so we have a controller installed. We have a Docker image behind KEDA that is basically the function that we built. And now we have external events, and this basically container is now listening to that external event. So when I will receive a message here, it will go to the KEDA. KEDA will say, okay, what kind of container would you like me to run? And it will spawn that container. Now, when the next event will come in, it will basically spawn a new container, and so on and so on and so on. Okay? So let's go back to the to this information, and here what I will do is say watch pods. So now let me monitor the pods, and now let me go here and say I would like to add a message. Happy times 1. Second message. This is soon is lunch. Send a message, and now if I go back, we should see two containers to spawn. Maybe this will be faster. Let me send the message again so that you can see. Blah. Blah 2. Okay, so here you see new basically containers are spawning based on the message that I sent into the storage queue. Now he's basically pulling the Docker image, creating the Docker image. Now in this case, you will see that when the Docker image is done, it will basically destroy the image, and I will get back to to the same level as before. So how it's done behind the scenes? If you check the deploy, you will see that it uses all of the features that it has behind the scenes. So here is hello Keda. So kubectl get HPA, and here you will see that it has a deployment which uses horizontal port autoscaler in this case. Okay. So this is really fine, but what if my machine starts working? But what if, we want to have unlimited scale? So we are reacting based on the messages that are coming in. But now imagine that you have, for example, 2 nodes, and those nodes are full. So it's not able to process those messages. It's not able to create new containers. So nodes have upper limits as well. So there are kind of limits in Kubernetes. Currently is 50,000 nodes and 150,000 containers in general. So that is the upper limit. So in order to fix that problem, we want to scale on demand. So imagine that you have some code that is executing, doing some really complex stuff, and then it dies. You don't want to use your production. You want to scale, indefinitely. Maybe you will need 1 container. Maybe you will need 5 containers. Maybe you will need 100 containers. So you would like to have this ability to use the same options, but you would like to use something else. So that something else is called virtual kubelet. So the idea behind the scenes is leveraging something that we have as a service. It's called Azure Container Instances. So in double quotes, it's basically serverless for containers, in short. So the idea is that you span a container that you need to run. What you have is a container. You specify that you would like to run on Linux. You specify how many CPUs, how many memory do you need, and it will basically execute and create in few seconds. So the idea is to run 1 container, per 1 container per service that you create in this case. So how does this look like, and why should you take in consideration container instances? So it's built per seconds. So you execute, you pay only for that stuff that you execute. The second one is you don't care about where this stuff runs. You only need Linux, you only need Windows, and that's it. So imagine we have a node pool in our case where in this node pool there are only Linux machines. What if I need to run Windows machines? How can I do that? So adding a new pool, adding new virtual machine can take time. So it can take like 2 minutes, 3 minutes, which can be quite costly. I need to have, for example, Windows containers up and running in few seconds. So in order to solve that problem, there was an internal hackathon, and the result of this internal hackathon was basically a virtual kubelet. If you remember the architecture in the beginning that I explained, where you have one component that is basically a daemon that is communicating with the master, giving him back the information about what is happening on the node itself. Here you have the same stuff. The only idea is that it's basically virtual kubelet. It's basically an interface that represents a kubelet. So instead of kubelet giving instructions to the node to basically create new pods with containers, with workloads, it will basically do Azure Container Instances behind the scenes. So how does this work? Very simple. We have a connector which you can then enable by default. You can add it as an add-on. You can delete it. You can it's really easy to get started. So let's start with that part, and you will see how this works. So if we go back here, and we say that we have kubectl, that we have nodes, right? If you noticed, I have 2 nodes. So the first one is basically virtual kubelet. Now, the naming here that you see is basically my naming. And as you can see, I'm really bad at naming. So the first one is created by default when you enable that you would like to have virtual nodes. The second one is my name, which is a little bit cumbersome. So how to see changes between these two? I can say, give me information about what is happening behind the scenes. So because of the metric server, I can get back the information, how much memory, how much CPU, how many stuff is basically behind the scenes. Now, Kubernetes in this case did ask kubelet, give me back information, how much stuff did I use. But in this case, I didn't get any information because I don't have a physical, physical server behind the scenes. So I have a lot of stuff that I need to run. So what we will do is we will run just virtual kubelet. So so let me just repeat this. So I have two things that I would like to run. So the first one that I will run is basically virtual kubelet for Linux, and then I will run virtual kubelet for Windows. So it uses, like I said, ACI behind the scenes. So if you create a resource here and say that you would like to have container instance, it will ask you a few things, and here it will ask you, name, container, image type, image name, what kind of operating system would you like to have, and would like to have Windows or Linux. So let me show you, this is the page for container instances, and currently I don't have any, okay? So what I will do is run first Windows. Let me go back to this one. First, what I will do is say kubectl apply f virtual kubelet Windows. So I'm running Linux, Windows. So if I go here and refresh, you will see that there's something that is happening behind the scenes. And here you see that I have something that is running in a specific resource group, which is called MC_the task and so on. So it's basically a resource group that is created by AKS behind the scenes, where all the virtual machines are inside. It's hidden from you, but you can access it. You can do whatever you want. But the problem is it will go, bye-bye. So if I go now back to the cluster, let me just show you how this virtual kubelet looks like. This file. So it's nothing more than just, I'm defining that I would like to run an image from our Microsoft that only have IIS installed, nothing more. So it's really a simple one. The only stuff that you need to be aware of is how to define where this container will spawn up. So in this case, I'm defining that it will be basically on the operating system Windows, and it will be a virtual kubelet that will be running this node. So what I can do now is do the following: kubectl get svc, and in this case, because this is a deployment, sorry, kubectl, where is it? Deployment. With the deployment, you see nano server. Now, what I will do is do virtual kubelet dot, I think, YAML is the same one, but for Linux. So I will run the Linux one as well. So here you see that I'm defining that I would like to have 1 gig, 1 CPU, and I would like to run it on virtual kubelet. But what is the benefit of this? If I want to scale deployment, let me just see the name of deployment because I forgot the name. It's nano server IIS. So here you see that I have now one of this. I can go back and say, because this is a normal, deployment, I can say scale this deployment with the name of nano server dash IIS replicas, for example, equals 2. And with this one, if I go back to the container instances, you will see that now when this will refresh, I have 2 instances that will run behind the scenes. So imagine you know, I have workers are doing the stuff, but I'm not touching them, so I still have the control. But if I go inside of this nano server, you will see that I have IP, you know, assigned, so I can access it. So if I go to the URL to this specific IP, I can basically get to the server behind the scenes. So if I want to scale down, or if I want to delete the deployment, I just go back and say I would like to delete the deployment, delete deploy nano server dash IIS. And now if I go back to the instances part and refresh this stuff, you will see that this, you know, nano server instances will basically, you know, go away. So I can really easily plug in existing functionality with the stuff that Azure provides. Okay, that's all from my side. The only stuff that I want to show you is this one. So we have Azure developer community. So here you will find all of the samples, all of the stuff that you need to, you know, all the presentations, links, demos, all you need, free workshops, you know, all of the resources that is available for you on this link.